We're going to have a look at some questions that involve working out the area and the perimeter that have of shapes that have got sectors in them or are sectors on their own. So in order to do that, to find the perimeter and the area of sectors, the fraction of the whole circle must be found first. Now this is a little bit of review for some of you, but let's have a look and see how it works. To calculate the perimeter of this sector, first of all, let's identify the fraction of the circle. So we can say that the sector is 30/360ths of a circle. That's the first point. So therefore, we would say that the curved length is going to be 30/360 times by the circumference of a circle, which is 2 times pi times r, the radius. So our full equation, or the part that we've got to evaluate, is 30/360 times by your 2 times by your calculator pi times, in this case, a radius of 8. And when we work this out, we'll give this an answer of 4.189 centimetres. And that will be to 3 decimal places. Once again, remember, it's rounded because of pi. All right, what about the perimeter? So we could say, therefore, the perimeter would be equal to that curved surface of 4.189 plus the 2 radius lengths of 8 centimetres. So that's 8 plus 8, which gives a total of 20.2 centimetres, and that's rounded to 1 decimal place. So don't forget, when you're asked to work out the full perimeter of the shape, you must include the radiuses in that, because you will find that a lot of people forget that and end up with an incorrect answer. What about this one here, calculating the area of this sector? Well, let's take the angle first. The sector angle. So we could say that the sector is 50/360, or if you like, 50/360ths of a circle. Now there's no need to actually simplify this down because your calculator will work it out. So let's go straight into our answer. The area, therefore, must be equal to the fraction 50/360ths of the full circle, which is pi times r squared. Now when we finish this equation, we get 50, or substitute in, we get 360. Remember, the only thing we need now is the value of the radius, which in this case is 12.3. And we're going to square that radius. Now there's no need to put the brackets there, but it helps to show that that whole amount is going to be squared. So when we simplify this down, we get 66. Now I'm going to round this to 1 decimal place, and if you look at it very carefully, we will have a significant 0 there, as we have discussed before. So it rounds down to 66.0, and we must write down here that it is to 1 decimal place. So that's our level of accuracy. All right, let's move on. Here's what we call a composite figure, because we've got a sector and a rectangle, but carefully read the question. We're looking at the perimeter of this shape. So be careful that you don't go and work out the area of something that you don't have to. So we could say, first of all, that the curved length would be equal to, there's our angle there, 70, so that would be 70/360ths of the circumference of a circle, which is 2 times pi times the radius. But let's put the radius straight in this case, and so you can see there it is 4 meters, or 4. So we'll put this to a few decimal places just so we can have a certain level of accuracy. 4.887 metres. You check this with your calculator. So we'll put this as 3dp, and then later we'll round it down to 1. It's always good to have a few decimal places. In fact, some people recommend you give the full calculator display, and I think that's not a bad idea. And then when we do our final perimeter, we get our curved distance, 4.887, and we add to it all the other lengths. So let's see, we've got a 1.5 there. What I might do is just to tick these off so we don't use them again. Now we can go up this way here, which is 4. And we've got this distance here also, which is the same as this one. Remember, they're all marked in the same. There's a 4. So we've got that one. We've got the curved surface, so we've only got this one here. So this is I've sort of squashed up the room here a little bit, but we'll just write it in here as 1.5. And so giving all that together, we're now going to round this down to 1 decimal place. It should give us an answer of 15.9 metres, and we'll put here to 1 decimal place. You've just got to be careful that you include all of the necessary lengths when you work the composite perimeter out. All right, let's have a look at just one more example, this time working out not perimeter but area. So we'll call this one here our area of a sector, so we'll call this area 1, and we'll call this area 2, and as you can see that it's a rectangle. We double check that all the units are the same, centimetres and centimetres. So we can start the area 1, would be equal to our fraction of a circle, 55/360ths of, now it's area, so it's pi times the radius squared. Now the radius is this distance here, which is the same as this, 135, and that's all squared. Now our area 2 would be equal to the length times the breadth or the width of the rectangle. So that would be 135 times 81. Remember, not perimeter but area. So when we put all this together, we would get our total area equals, we'll go area 1 plus area 2, and I'm just going to write that in and get you to double check it. So we'll go 19,682.4 centimetres squared, and that's to 1 decimal place. So the main thing to remember when you do these is, first of all, are you calculating perimeter or are you calculating area? That's very important. Don't mix that up. And secondly, when you write down the perimeter, make sure you've checked that you've included all the sides. In a particular case, not like this one, but in the previous one, we'll just go back. In this previous one, where you don't leave out your radiuses. You use your curved surface, but also use your radiuses. And in all of these cases, that's a very important part of the procedure. So there's your review. Now you need to practice those and make that make it confident that you can do these successfully, including all the bits and pieces. Once again, I will emphasize, read the question. Is it area or is it perimeter that you're calculating?